Okay, I want you to find f of 3, and they give you this relationship that involves an inverse of f, all right? There are a couple of different ways of doing this. I want to point out that there is a video over here where I originally saw the problem. I thought it was a good level problem for my pre-calculus students. All right, let me go through what I suggest the pre-calculus students do is you simply look at that and try to figure out what f inverse is, all right? So the way I would do that is I'd write down f inverse is equal to, let's see, 4 times f inverse minus 1 over x plus 1. I'd multiply both sides by x plus 1, clear the fraction. You get x times f inverse plus f inverse. Again, we're trying to figure out what f inverse is, by the way. On the right side, what do you get? Well, these things cancel off, and you can get 4 times f inverse of x minus 1. Now I'm trying to get the f's onto one side, or the f inverse on one side. So I'm going to subtract this from both sides. And what do you get? You get x f inverse minus 3 f inverse equals minus 1. The next thing I would do is I'd factor out f inverse. And what do you get there? You get x minus 3 equals minus 1, or f inverse would be minus 1 over x minus 3. I can multiply top and bottom by minus 1. You don't have to, but I want to do that to make it a positive on top. You get 1. On bottom, you get 3 minus x. That's what f inverse is. All right? Then what do? I find out what f is. How do I do that? I found the inverse of f inverse, which is f. And how do you do that? Well, let's remind you. Set this to y, the function, by the way. Interchange x and y. And now solve for y. And what do you get? We get 3x minus 3y is equal to 1. I'm trying to solve for y, by the way. I can say 3x minus 1 equals 3y. And then I would divide through by 3. And what do you get? I'm sorry, I made a mistake already. This is the x over here. Let me make sure I did that. 3x minus, I really screwed up. I got to stop. Let me start that again. So it's 3x minus xy equals 1. And then what do? I'm going to try to get the y on one side. So it's 3x minus 1 equals xy. And then divide through by x. And what do you get? 3x minus 1 over x is equal to y. And this is the function, or the inverse of the inverse. So it's going to be, this is f of x. What do they want to know? They want to know f of 3. And I think I can do that now. F of 3 is going to be 3 times 3 minus 1 over 3. That's going to be 9 minus 1, which is 8 thirds. All right, that's one way of doing it. Another way of doing it, I want to go through that with you, is to simply say, in the relationship that, they want to know what f of 3 is. I'm going to say, I don't know what that is. I'm going to call it u, but I don't know what that is. Some value here. There's some value. And what do? If that's true, f inverse of u would be equal to 3. So I just take my original equation, which was f inverse. Instead of putting x down, I can put u now. I'm going to say equals 4 f inverse of u minus 1 over, x is u, right? So u plus 1. Now, what's f inverse of u? It's 3. I'll put this over here. 4. What's f inverse of u? It's 3 minus 1. And then I get u plus 1. I got to solve for u now. What do you get over here? 3. 4 times 3 is 12. 12 minus 1 is 11. And then you get u plus 1. I'm going to multiply both sides by u plus 1. That's 3u plus 3. And then you get 11. And 3u, take 3 from both sides, is 8. And u would be 8 divided by 3. Now again, someone says, what you just do there? I just found out what f of 3 was. Because f of 3 equals u. And I just found u was 8 thirds. all right? Now granted, I would say this is probably the most direct approach, one that you're most familiar with. But realize, inverse is basically just rotating coordinate system. So, again, if you have f of 3 equals some number, let's say u, that means f inverse of u would equal 3. And that's something you could see too. But again, this is the most direct approach, the initial one. It's the one I'd expect most pre-calculus students to take. But this is also good. This is a good technique also. It may not be so direct, but it's another good technique over there. Thank you.